Welcome back. So, by the way, the course, the part of your course at the moment is Strand 3.4, but I put that in as Leaving Cert Maths LCM 34. I'll copy paste that into the Padlet we're using right now. Into the OneNote I'm using right now. Okay, and so we're using a thing called a trapezium rule. It's a method not for calculating area, but it's pretty good at it. We can approximate area. So what we do is we basically cut away smooth curves and draw in the straightest line between the points on the function. So we often underestimate if the curve is going above, but we can also overestimate. So if I had a point here, we'd end up overestimating because we would end up including a bit in our trapezium that didn't exist. So sometimes if the concavity keeps changing from smoothly curving from the angle getting smaller, that's a downward facing concavity, and upwards. So basically as they change, sometimes maybe you can kind of offset losses and gains against each other. There's another method to become more precise, and that is basically to shrink the interval. It's kind of neither here nor there for us. In each particular case, we're just using the actual formula for a trapezium, which is y1 plus y2 over 2, that's the midline value, multiplied by the height. When you end up adding y2 plus y3 over 2 times the height, what you have here is, you see, you have the y2 appearing twice, but y1 will only appear once, and at the very end there'll be a y value that appears once. That's the explanation for why we only see these two guys once, because they're kind of all on their own, whereas each one of these got to play twice in the formula. Got to be in two terms. Right? I haven't put it there, but that's the explanation. And then there's a little bit of factorizing out the h over 2 and a little tiny bit of algebra. You don't have to prove it. I'll just throw it in there and say that's where it comes from. Okay, so and I just want to show it to you in action here how the trapezium rule works. So this is a real weird shape, and it's a mathematical shape. There's an actual function here. Oh, that's just got me thinking. Maybe we can work this and put in our own formula. But look, that's for another day. And that's for you to revisit this. So notice that if I put in a lot of intervals and I make h quite small, the precision will go up, the accuracy of the thing. And I just say this isn't just working out farmers' fields areas and the size of lakes and things. This is used to calculate things other than area, because see, this area under a curve often has a physical meaning that isn't just literally area. It's quite important. There's a few different methods for evaluating area here. Integration, which you'll be doing next year, is the best of all, and it can, in certain cases, it's generally absolutely correct. Okay, down to business. Let's just start using the formula to calculate area, as we have to do here. Okay, so you basically always want to write the formula, h over 2 times the first, no harm in practicing a word equation, so you get familiar with the process. First plus last plus double, let me write that as double, plus double the rest. So we have a thing called nested brackets here, the rest, so I'm using a square. I'll have to have a bit. Okay, the first plus last plus double the rest. Okay, half the height. And remember your perpendicular height over 2, half the height times the first plus the last plus double the rest. Sounds good? Okay, what is half of 24? 12. What's the first value? 84. What's the second value? 96. Okay, so let's write them down. 84 plus 96. I'm not going to do any heroics here. We're going to put it all in the calculator. Yeah. And then I got to put all the other values in here. Now you will find, you'll be tempted to go straight to your calculator, and if you're steady and you're correct, you won't have a problem there. The issue will be you might lose partial credit if you, I see another 54, but it's probably not worthwhile using multiplication there. So, and you do want to keep track, so no harm in marking them off as you go. I got another 66, and I got 96. So I very unconventionally wrote them in 2 columns because it doesn't really matter. So what matters now most of all is that I plug this into my calculator. Okay, and I do certainly I want to kind of change the order. Oh, I think this will work. Should work now. Yeah. Okay. So clear our calculator. 12 because we've already halved the outside, but sometimes you'll be put a fraction bar there. Just for the sake of the general method you'll be using here, you'll be putting 24 there, coming down here for a 2. You'll be coming back up here, you'll be starting a bracket. You'll be writing in 2 numbers. Now sometimes they're 0, or one of them is 0, but generally speaking, you'll be writing in 2 numbers, and you'll be going plus a double, another bracket. So we're nested brackets, and we've got to make sure we end up with 2 brackets at the end. Okay, I see 54 twice. I gotta just like a little bit of cop on here, and we can double them up to thing. I don't fancy doubling the 266 right now. I think it's just as quick to just plug it in like that. I got 96 and 54. Just to double check, have I done that? Have I done that? Now I have 96 and 45. 96 and 45 both to go in. So you can certainly say it's just this bit of tedium, but you want to hold your concentration. Make sure it's gone into the calculator correctly. And that comes out as 11304. 11304. Okay, now I would want to get the context, and of course you really watch out for any mixed units or anything there which would trip us up, but that looks correct. Thank you. Oh, just one more thing I forgot to say. We should have a little bit of a celebration at the end and bring out the fancy color marker. Okay, and have a little bit of fun with it. Okay, we'll leave that.